Hello everyone, welcome back to MathWorks by Vishal. So since we are almost done with the April session of JEE Advanced 2026, right? Now it is the high time to shift our complete focus towards the preparation of JEE Advanced 2026. Now in this video, I'll be discussing complete concepts and also PYQs related to planes and also 3D geometry. So let us start our JEE Advanced preparation together, right? So planes is one of the chapters generally neglected by many students while preparing for JEE mains because we do not have this planes chapter in the current JEE syllabus, JEE main syllabus, right? That is why I thought in this video I'll start discussing about planes so that we'll get some good idea about planes and also perfection while solving the PYQs questions together. Okay, so let's start with the very basic concepts about planes. First thing is the general equation of plane. General equation of a plane. So a general equation of a plane is given by ax plus by plus cz plus d is equals to 0, where a square plus b square plus c square is not is equals to 0 for obvious reasons because all the three values of ABC cannot be simultaneously 0. If all of them are zeros simultaneously, then there is no meaning of the equation itself, right? So that is the reason. The first thing is the general equation of the plane is ax plus by plus cz plus d is equals to 0. Where here there is a importance for this coefficients of xyz here. Because if you take a plane, something like this, a rough diagram, let's take this as the plane. Okay. So if I try to construct a line which is perpendicular to this plane like this. So any line which is drawn perpendicular to a given plane is called the normal to the plane. It's called the normal to the plane. So as you can see, we can construct infinite number of normals to a given plane because I can change the position of this perpendicular line anywhere so that we can draw infinite number of normals to this one. Okay, and the main thing is wherever you draw this line which is perpendicular to this plane here, all those normals will be definitely parallel to each other, right? So as you can notice here, even if I draw a normal somewhere here or somewhere here, the main advantage is all these normals are going to be parallel to each other. Okay, so that's the importance of normal to a plane. And here, this is a normal to the plane, right? Now this normal here will have the drs. This normal will have the drs as a comma b comma c. So whenever we see a equation of the form ax plus by plus cz plus d is equals to 0, immediately you have to look at the coefficients of x comma y comma z here. The coefficients of x comma y comma z will always give you the drs of the normal to the plane. Okay. For example, if I write an equation of plane something like this, 2x minus 3y plus 4z plus 5 is equals to 0. So the immediate thing we have to imagine is there is a plane something like this here, and then you need to immediately imagine a normal to this plane also here. Now that normal will have a set of drs, right? Those are given by the coefficients of x comma y comma z. That is, in this case it will be 2 comma minus 3 comma 4. So this is how you have to interpret the general equation of a plane. I hope it is clear. And also, as you can see, even if you take any other normal also here, all these set of normals will be definitely parallel, right? But we know that any two parallel lines will have the same set of drs, or also the drs will be in the same proportion, right? So which means you can take any one of the normal as the normal to the drs. It won't make a much difference here. So this is the first thing about a plane, that is the general equation of plane. Now we have the very basic planes here. Suppose if you take coordinate axis like this, x-axis, y-axis and also z-axis, you need to imagine this properly. X, y and z-axis, okay? And let's take this as the positive z-axis here. Now all these three will be intersecting at origin here in this way. Now if I try to take the XOY plane, XOY plane, XOY plane is nothing but a plane which is containing x-axis, y-axis and also origin, something like this here. Okay, you need to properly imagine here. So if I take XOY plane, as I told, what is XOY plane? It is a plane which is containing x-axis, y-axis and also origin. So the equation of XOY plane is given by simply z is equals to 0. And what is the reason behind that? Because if you take any point on the XOY plane, the z coordinate is always going to be 0, right? So that is why we write down the equation of XOY plane as z is equals to 0. In the similar way, when we have YOZ plane, its equation is given by x is equals to 0. And then one more basic plane is XOZ plane. So the equation of XOZ plane is given by y is equals to 0. So these are the three basic planes that we know when we look at the coordinate system, that is XYZ axis here. Okay. Now we have different ways we can express a plane equation. So let's try to see the various ways to express a plane equation, or simply let's call it as various forms of planes. Various forms of planes. So the first form is like this. Whenever we have a point and the drs of normal. So let's take a plane something like this here. Now in this plane, let's say we know a point here, point A, x1 comma y1 comma z1. Okay, so point A is known to us, which is given, which will be given in the question. Now, and then along with this, we know the drs of the normal also. Okay, let's assume we know the drs of normal here. So this is the normal, and let me assume the drs of the normals as a comma b comma c. So these drs are also known to us here. Now when we know a point in the plane and also the drs of the normal to the plane, we should know how to write down the plane equation. This is one of the basic forms of planes. So just imagine, like I'll tell you the formula also, but you need to know how to construct a plane equation whenever a random question is given to you. First thing is, always assume a general point in the plane, a locus point. You can take it as x comma y comma z here. Okay. Now what you need to do is simply find out the drs of this AP here. Drs of the line joining A and P. So drs of AP would be x minus x1, comma y minus y1, comma z minus z1, because in the in few of the previous videos also I have already told you how to find out the drs of line joining 2 points, right? So that's why that's how we got the drs of this the line AP here. Now one thing you need to understand here, when you take the plane and in that plane only you have taken the 2 points A and P, which means the line AP lies on the plane, whereas this normal here is exactly perpendicular to the plane. So which concludes that this line AP here is perpendicular to the normal. Okay, so normal to a plane will be always perpendicular to any line which is lying on the plane. So clearly we have the drs of AP, we have the drs of normals also, and we know that the two straight lines are perpendicular to each other. So whenever we have two lines whose drs are known to us and are perpendicular to each other, what is our formula? A1 A2 plus B1 B2 plus C1 C2 is equal to 0, right? So let's apply that, which will be A into x minus x1 plus b into y minus y1 plus c into z minus z1 is equals to 0. So this is the first formula related to construction of planes. Okay, and you should know which formula to apply under what scenario, right? So for example, they'll give you something like this here. In a plane, there is a point 1 comma 2 comma 3. 1 comma 2 comma 3, and then if you know the drs of this normal to the plane as some 1 comma minus 2 comma 5. So this is like the point x1 y1 z1 given to you, and these are the set of drs known to you, a comma b comma c. So if you want to write down the plane equation in this case directly, this is your formula, which is 1 into x minus 1, and here b value is minus 2, so minus 2 times of y minus 2, and then plus 5 times of z minus 3 is equals to 0. So this is how you need to construct the equation of plane when a point on the plane and also normal drs are known to us. Okay, and also there are there are different ways to write down this equation here. One is Cartesian form, other one is the vector form. We'll discuss that one also. And the only difference is here you are dealing with points in the Cartesian format. There you will be dealing with vectors actually. So let's do both of them simultaneously. Imagine you have a point A whose position vector is A bar. Okay, whose position vector is A bar. Now imagine there is a vector which is called normal vector. Let's call it as n bar. What is n bar here? It is a vector which is perpendicular to the plane, and that is called normal vector. Now, if you want to construct the equation of this plane on which you have a point A whose position vector is A bar and the normal vector to it is n bar. Once again, the first step is always assuming the general point on the plane. So I will take a general point on this plane as some point P here. But since it is vectors, I should be taking in the form of some R bar. Okay. So what is R bar representing here? It is any general point on that plane. Now once again, what I am going to do is I am going to join this A and P and form the vector AP bar. Now once again, what's the clear observation here? The vector AP bar is on the plane, whereas n bar is exactly perpendicular to the plane. So which means I can say that the vector AP bar is perpendicular to n bar. And whenever two vectors are perpendicular to each other, what is our concept? Dot product must be is equals to 0. So that is exactly what I am going to do here. AP bar dot n bar is equals to 0. And then what is AP bar actually? OP bar minus OA bar. And dot product with n bar is equals to 0. And finally, OP bar is nothing but R bar. That is what we have taken the general point position vector. And OA bar is nothing but A bar. And finally, we get the vector form of plane. Okay, the previous one is called Cartesian form and this is called a vector form. And that is R bar minus A bar dot n bar is equals to 0. What is A bar here? It is a point, a given point on the plane. R bar represents any point on that plane and then n bar is the normal vector to this plane here. Okay, so this is the first form of the plane that we should know. Okay, next one. Second one is intercept form. Intercept form. It is somewhat similar to intercept form of a straight line actually. So when we have the intercept form of the plane as x by a plus y by b plus z by c is equals to 1, where a comma b comma c are not is equals to 0. Okay. So this is called intercept form of the plane here. Okay. And what do we need to understand from this one? Here A is the x coordinate of the point where the plane meets the x-axis. Okay, which means the plane actually passes to the point A comma 0 comma 0, and this is called y-intercept here, which is 0 comma b comma 0, and this is called z-intercept, that is 0 comma, that is the plane passes through 0 comma 0 comma c. So this A comma b comma c here are called the x comma y comma z intercepts of this plane. Okay, na? And this is one of the frequently used forms in planes, that is intercept form, right? Next, the third one is equation of plane passing through three given points. Passing through three given points. Okay. So we have a small trick actually to construct equation of any plane. We need simple logic. I'll tell you the logic behind it. If you understand that logic properly, you can write down the equation of any plane even if you don't remember the formulas also. So let's try to concentrate here. I'll take a plane. In this plane, we have three points, something like this. Okay, let's take the point A as some x1 comma y1 comma z1, and point B is x2 comma y2 comma z2, and then some points C like x3 comma y3 comma z3. Now we need to write down the equation of this plane, which is containing the three given points A comma B comma C. Now the simple trick here is always first assume the locus point on this plane. So let me take the locus point somewhere here, point P. x comma y comma z. Okay. So the trick here is whenever you want to construct a plane, always try to form three lines which are coplanar. Okay. If you are writing in the form of vectors, you construct vectors, and if you are writing in terms of Cartesian form, construct lines. Okay. So what I'm going to do is I'm going to take three lines here: AP, AB, and AC. Okay. I'm going to take three lines here. So what I'm going to do is I'm going to write down the drs of these three lines one by one. So drs of AP are nothing but x minus x1 comma y minus y1 comma z minus z1. Now then drs of the line AB here. So drs of the line AB are x2 minus x1, y2 minus y1, z2 minus z1. Similarly, I'll take the third line as well, AC, which is x3 minus x1, y3 minus y1, z3 minus z1. Okay, so what you do is always take three lines which are coplanar here. Now just apply the det of this is equals to 0. Okay, because whenever we have three coplanar vectors, what's your idea? Determinant of all the coefficients should be is equal to 0, right? So that's the logic behind this actually. So det of x minus x1, y minus y1, z minus z1. Similarly, x2 minus x1, y2 minus y1, z2 minus z1, and x3 minus x1, y3 minus y1, z3 minus z1 is equals to 0. So on expanding this determinant, you are going to get the equation of the plane passing through these 3 points here. Okay. So this is one of the most important forms of the plane which passes through the three given points. Okay. And I'll tell you the trick also for the next cases. You just need to understand one simple thing. What is that? Whenever you want to find out the equation of a plane, you try to form three lines, or you try to take three lines which are coplanar, and then simply apply the det of their coefficients is equals to 0. Now, for example, if I take the fourth case here, try to understand. In this case, let's say the plane is passing through two given points, and it is also parallel to a given line. It is also parallel to a given line. Okay. Now let's imagine the diagram. Okay. The first thing is always imagine the proper diagram. Then you do it. So two given points, right? So let me take the point A to be somewhere here. That is x1, y1, and z1. Now one more point is also there. Let me take the point B here, which is x2 comma y2 comma z2. Now, and here the difference between the previous one and this one is we have 2 points on the plane, and there is a line given to us which is parallel to this plane here. So you need to imagine properly that there is a line something like this which is lying exactly parallel to this plane. Now let us take the line equation also. Some x minus alpha divided by a is equals to y minus beta divided by b is equals to z minus gamma divided by c. Okay, and let's take this as some line L here. Now once again, what's our trick always? To write down the equation of a plane, first thing is assume the locus point on the plane. So take the point P here. The usual locus point is what? X comma y comma z. Now what is the simple trick that I told you? Simply form three lines, construct three lines. So let me do it. This is one line AP, and then AB is one more line here. Okay, and let me write down here. This is AP one line, AB one line, and also one more line is L here. So after taking these three lines, now the idea is to write down the drs of these lines here. So let me write down the drs of this line. AP drs are directly x minus x1, y minus y1, z minus z1. Similarly, the drs of AB are x2 minus x1, y2 minus y1, z2 minus z1. And the drs of L are nothing but a comma b comma c. And what is the trick that I told you? Just apply the det of these three drs is equals to 0. That will give you the equation of plane, which is det of x minus x1, y minus y1, z minus z1. And then x2 minus x1, y2 minus y1, z2 minus z1. And then finally the drs of the line L, that is a, b, c is equals to 0. So by expanding the determinant of this one, you are going to get the equation of the plane which is passing through the two given points and also parallel to the given plane here. Okay, I hope you understood how we are constructing the plane equation, right? So let us take one more case also, you'll get more clarity. So this is fifth case, right? Fifth case. Now, in this case, plane is passing through a given point, passing through one point, one given point, but parallel to two given lines. And the lines must be non-parallel. The two lines that they are giving should be non-parallel, obviously. So what you are going to do is, first thing, imagine the diagram. Take the plane, and in that plane, there is a point known to us. I'm going to take that point as x1, y1, z1. Now you need to imagine very carefully here. So let's say there is one plane here, which is one line which is parallel to this one. So let us take it as line L1, that is some x minus alpha 1 divided by a1 is equals to y minus beta 1 divided by b1 is equals to z minus gamma 1 divided by c1. And let us imagine one more line parallel to the same plane, but making sure L1 and L2 are not parallel to each other. So since we are drawing these three-dimensional figures in the two-dimensional plane, it is looking like L1 and L2 are parallel, but actually in actual scenario, they are not parallel. You need to imagine properly. So this is like a plane to you, and this is one line, something like this, which is parallel to this plane here. And you need to imagine one more line, something like this, that is also parallel to the plane, but this line L1 and line L2 are not parallel, right? So in that way, you need to imagine here. Okay. So let me take this x minus alpha 2 divided by a2 is equals to y minus beta 2 divided by b2 is equals to z minus gamma 2 divided by c2. And once again, to construct the equation of plane here, what is our idea? Take the locus point. So let me take the locus point here once again, x comma y comma z. First thing, as usual, we'll take the line AP here. So what are the DRs of this AP here? Again, x minus x1, y minus y1, z minus z1. Okay, and then next here we'll take the DRs of the first line L1, which are given by A1, B1, C1, and then L2 will have the DRs as A2, B2, and C2. And once again, simply write down the det of all these DRs is equals to 0, which will give you the equation of plane. Okay, so these are all shortcuts to write down the formulas directly. We have a proper derivations of all these by using vectors actually. So these are like only shortcuts. I'm not discussing the complete derivation and proof of this. Okay, right. So in this case here, the plane is passing through a given point and also parallel to two given lines which are not parallel to each other. So as usual, what we have done, the DRs of AP and the DRs of the first line and the DRs of second line. And then apply that is equals to 0. Now you would have understood why the L1, L2 lines must be non-parallel here, because if they are parallel, what happens? The row 2 and row 3 of this determinant are going to be proportional, which will make 0 is equal to 0, which means there are infinite number of planes which are possible if the lines L1 and L2 are parallel to each other. Okay, you need to think about it properly. Imagine two lines which are parallel to each other, and imagine a plane which is parallel to these two parallel lines. So what happens? There are infinite number of possibilities. So that is the reason I told you it must be definitely non-parallel. If they are parallel, infinite number of cases are possible. Okay. So this is the fifth case. So these are the five cases, right? Now there are other cases also where we have to construct the plane equation based on the given scenarios. But before going to the next cases, let us try to discuss three important points actually, because based on that, many questions will be framed in JEE Advanced especially. Okay. So let us look at that. I think you know this one. Many of you will know this one already. That is perpendicular distance, foot, and image of a point with respect to a plane. Okay, so let us discuss all formulas and concepts related to all these at a time. Let's take a plane in the general form. Okay, so let us take this plane as ax plus by plus cz plus d is equals to 0. Now let us take a point P x1 comma y1 comma z1 which is not lying on this plane. Okay. Now first thing is perpendicular distance. That is, if you drop a perpendicular from the point P onto the plane, and this distance here is nothing but the perpendicular distance, right? And we have a direct formula for this one. And let's take that perpendicular distance as some P here or some L. So perpendicular distance L is equals to modulus of ax1 plus by1 plus cz1 plus d divided by square root of a square plus b square plus c square. Direct formula, and as you can notice, it is almost similar to the perpendicular distance formula from the straight lines chapter, right? And that's the first one. And second one is the foot of perpendicular. So wherever this perpendicular from P meets the plane, that is called the foot of the perpendicular. So point Q is foot. Now to find out the foot of perpendicular, we have the direct formula just similar to the foot formula from straight. So the foot formula will be alpha minus x1 divided by a is equals to beta minus y1 divided by b is equals to gamma minus z1 divided by c is equals to minus of ax1 plus by1 plus cz1 plus d whole divided by a square plus b square plus c square. This is the foot of perpendicular formula, and here alpha beta gamma is nothing but the foot of perpendicular. Okay, and similarly we have the formula for image also. And what is the concept of image? If you want, I can draw one more diagram, just a rough diagram. Image is nothing but the reflection of the point with respect to the plane, right? So if this is the original point P, which is x1 y1 z1, and image will be on the other side. Let me call it as some P dash, and let's take it as some small l comma m comma n here. And what is the main point here of image? That is the foot of perpendicular, whatever we have written here in the previous step, the foot of perpendicular from the point P will be acting as the midpoint of the original point P and also the image point, right? So if you want, I can write down that Q is image of P and P dash. And moreover, what is the main conclusion from the diagram here? The line PP dash is perpendicular to the plane. Okay, so we have to make sure the line joining original point and image point is perpendicular to the plane, and also that foot is the midpoint of the 2 points P and P dash. So this is the concept of image or reflection. And once again, the formula will be almost similar to the formula from straight lines. That is L minus x1 divided by A is equals to M minus y1 divided by B is equals to N minus z1 divided by C is equals to minus 2 times of ax1 plus by1 plus cz1 plus d whole divided by a square plus b square plus c square. So this is the formula we are going to use to find out the image of a given point with respect to a plane. Okay, so these three are the formulas which will be frequently used in many questions in JEE Advanced. Okay, let's see some questions based on whatever topics we have done till now. Okay, so let us try to get some clarity how to apply the formulas also, and I'll make sure I'll discuss all as many PYQs as possible simultaneously. So first, let us take a previous mains question. The distance of the point 7 comma minus 3 comma minus 4 from the plane passing through the points, and let's take it as point A, point B and point C. Now the thing is, if this is the point P, the first one, we have to find out the distance of the point P from the plane which is passing through the three given points, which means first of all you need to write down the equation of the plane. Equation of the plane. Okay. Now this is the concept of what? Plane passing through three given points, right? So this was the formula which we discussed. You can go through it once again. So let me write down the formula, which is det of x minus x1 y minus y1, z minus z1, and then x2 minus x1, y2 minus y1, z2 minus z1, and then similarly x3 minus y1, y3 minus y1, z3 minus z1. And let us try to expand this one completely, which will be that of x minus 2, y plus 3, z minus 1. This is minus 3, 4, minus 3, 1, minus 1, 1 is equals to 0. Now we know how to expand the determinant, right, which will be x minus 2 multiplied by 4 minus of 3, which is 1, minus of y plus 3 multiplied by minus 3 plus 3, which will be 0, and then plus z minus 1 multiplied by 3 minus of 4, which is minus 1, is equal to 0. It is a simple expansion of the determinant. Now let's see the remaining part. X minus 2, this will be anyhow 0, and minus z plus 1 is equal to 0. So finally what we get is x minus z minus 1 is equals to 0. So this is your required equation of the plane. Now what is the question? We have to find out the perpendicular distance from the point P 7 comma minus 3 comma minus 4 to the plane which we obtained just now. And we have just now discussed the perpendicular distance formula also. Let us try to apply that formula here. So perpendicular distance L will be is equals to modulus of, just substitute the point in the plane, that is 7, and minus of minus 4 minus 1 whole divided by square root of a square plus b square plus c square. So which will give you finally L is equals to modulus of 7 plus 4, 11, 11 minus 1 is 10, 10 divided by square root of 2, which will give you finally perpendicular distance is equals to 5 into square root 2. Okay. So this is a basic question based on the first one of the important equations of plane passing through three given points. Okay, it is covering both the formulas, perpendicular distance, and also one of the form of the plane. Okay, let's take the next question. This is also a question from JEE Mains 2023. Read the question. Let the image of the point P in the plane be the point Q. Then the distance of the plane 3x plus 2y plus z plus 29 is equals to 0 from the point Q. So by doing this question, we will know how to apply the image formula also. So let us try to apply the image formula here. So what is our image formula? L minus of, and let us take this as point P, x1 comma y1 comma z1, just for your reference. X1, y1, z1. Okay. So what's our formula? L minus x1 divided by a. And by looking at this first plane equation, a value is 1. And similarly, m minus of minus 1 divided by b value is 2. And then n minus of 3 divided by c value is minus 1, which should be is equals to minus 2 times of, this is image formula, right? So minus 2 times of, this will be 2 plus 2 into minus 1 minus of 3, that is putting the point in the plane left hand side, divided by a square plus b square plus c square, which is 1 plus 4 plus 1. Let's try to simplify here. L minus 2 divided by 1 is equals to m plus 1 by 2 is equal to n minus 3 divided by minus 1 is equal to, what is the calculation in the numerator part, which will give you 2 minus 2 will be cancelled out, and totally this will be minus 3 into minus 2, 6, 6 divided by 6, which is 1. Now if you equate first and last, you will get L is equal to 3. If you equate second and last, you get M is equals to 1. And then if you equate these two, third one and fourth one, then you will get N is equal to 2. N is equals to 2. Okay. So this is your image point here. So let us take this image point as point Q as per the given question, which is 3 comma 1 comma 2. Now look at the remaining question here. What we have to find out here, that is we have to find out the distance of the point Q 3 comma 1 comma 2 from the given plane. So let us write down the plane equation here, which is 3x plus 2y plus z plus 29 is equals to 0. We have to find out the distance of this point Q from this plane here. And once again, it is a concept of perpendicular distance. So perpendicular distance formula should be is equals to modulus of, we know the formula very well, 3 into 3 plus 2 into 1 plus 2 plus 29 whole divided by square root of a square plus b square plus c square. Let's finish the calculation also here, which is 9 plus 2 11, 11 plus 29, which will be 40, which is 42 divided by square root of 14. So this is your perpendicular distance from the point image point Q to the given second plane, 42 divided by square root of 14. I hope you have got some idea how to apply the image of the point with respect to a given plane, and also finding perpendicular distance from a point to a given plane. Okay. Next, let's take one more question also. And once again, this is a question from 2023 JEE Mains. Let us try to read the question. Let the plane x plus 3y minus 2z plus 6 is equals to 0 meets the coordinate axis at the points a comma b comma c. Okay. So you need to understand the meaning here. Suppose if this is the xyz axis, now there is a plane something like this here. Imagine properly. This is x-axis, this is y-axis and z-axis. They said that the plane is meeting x-axis at A, y-axis at B, and z-axis at C here. Okay, now here either you can find out the intercepts by putting x0, y0, and so on. Otherwise, you can convert the equation of first plane into intercept form as we just discussed. So let's do that. I can write this equation as x plus 3y minus 2z plus 6 is equal to 0, which is equals to minus 6. So I can write this as x divided by minus 6 plus y divided by minus 2 and plus z divided by 3 is equals to 1. So this is the equation of the plane here. Okay, I hope you are able to see this one properly, and which is exactly in the form of what? Intercept form of the straight line. Now, what did I tell you? What is the intercept form of the straight line? The denominators here are nothing but the values of a comma b comma c, which are nothing but the x, y, and z intercepts. So, since here x intercept is minus 6, which means the point A is going to be minus 6 comma 0 comma 0. And y intercept is minus 2, right? Which means the point B is going to be 0 comma minus 2 comma 0, and since the z-intercept here is 3, point C is going to be 0 comma 0 comma 3. Now you have got all the 3 points here. Now the question is, let's read the question. If the orthocenter of the triangle ABC is given as some alpha, beta and 6 by 7, we have to find out the value of 98 times of alpha plus beta whole square. Okay. So let us construct the triangle here first. This is your triangle ABC, and since we have got the all three vertices, it's a huge advantage to us. Minus 6 0 0, point B is 0, minus 2 0, point C is 0 comma 0 comma 3. Now they said that orthocenter is alpha beta 6 by 7, right? So we know what is orthocenter actually. It is simply the point of intersection of any two altitudes of the triangle. So let us take these two altitudes. Okay, and this is the orthocenter. Wherever the two altitudes of the triangle meet, that is nothing but called as the orthocenter. And that orthocenter actually is given as alpha comma beta comma 6 by 7. Okay. Now, how we are going to solve this question is again by using the concept of drs actually. Because as you can see here, the straight line AH in this diagram, observe carefully. The straight line AH, line joining A and orthocenter, is actually perpendicular to the line we see here. Okay, because it is all altitude obviously. So what I'm going to do is I'm going to write down the drs of this AH here. So we know how to write down the drs here. So drs of AH are simply alpha plus 6 comma beta comma 6 by 7, subtracting the respective xyz coordinates. Similarly, let's write down the drs of BC also by looking at that, which will be 0, 2 and 3. Okay, and then next here these two straight lines are perpendicular to each other. Now we know we know very well what to do. If there are two lines which are perpendicular to each other, then a1 a2 plus b1 b2 plus c1 c2 is equals to 0. So let us do that, which will give you alpha plus 6 into 0 plus beta into 2 plus 6 by 7 into 3 is equals to 0. So clearly this is 0. And finally, we get 2 into beta is equals to minus of 18 divided by 7, which gives you the value of beta as minus of 9 divided by 7. So this is your value of beta. Okay. So you got already the beta value. And next thing, I think you understood what we are going to do because we have applied AH perpendicular to BC. Now I can do the same thing for the one more altitude, which is CH here. So CH is clearly perpendicular to the line AB here. And let me write down the drs of CH here, which is alpha comma beta comma 6 by 7 minus 3, which will be alpha comma beta comma, this is 21, right? So minus of 15 divided by 7 are the drs of CH. Now let's calculate the drs of AB also here. We know how to calculate. Drs of AB will be 6 comma minus 2 comma 0. And once again, these two straight lines are perpendicular to each other. So let's apply the condition A1 into A2, that is 6 into alpha, plus beta into minus 2, plus minus 15 by 7 into 0 is equal to 0. Finally, we get 6 into alpha minus 2 into beta is equal to 0, which will give us 3 alpha is equals to beta. But already we know that beta is equal to minus 9 by 7, which will give you alpha as minus of 3 by 7. And once we know the values of alpha and beta here, we can find out whatever is asking in the question. Okay. I hope you can do the remaining calculation part. Okay. So this is an example related to the intercept form of the plane. Okay. And this is one of the previous JEE mains questions. So first of all, I'm trying to take all the PYQ mains questions so that we'll be perfect with the basic concepts of the plane, because when we go to the questions which are in JEE Advanced, it needs more in-depth conceptual knowledge and more properties actually. So we'll do that definitely in this video itself, but let us try to be perfect with the very basic concepts of planes. Okay, now let us take the next question. Yeah, look at this one. This is a JEE Advanced 2024 question. As you can see, it is a lengthy question definitely. That's why I told you, right? We need lot many concepts to solve a JEE Advanced planes based question. Okay. Let's read the question very carefully here. Hmm. A straight line drawn from the point P parallel to the line intersects the plane L1 x minus y plus 3z is equal to 6 at some point Q. Okay. So first thing, let us try to find out the point Q here. Okay. Let us go step by step. There is no need to worry. Point P is there 1 comma 3 comma 2. What we are doing is we are drawing a straight line through the point P parallel to a line which is intersecting a plane. So let's take this as the plane which is given by some L1 here. And what is the plane equation? X minus y plus 3z is equal to 6. So what exactly we are doing is we are trying to draw a line through this point P which is parallel to a given line like this. Okay. And what is this given line equation here? X minus 2 by 1 is equals to y minus 4 by 2 is equals to z minus 6 divided by 1. Now here they said that this line whatever we are drawing to the point P here, that is meeting the plane at some point Q like this. Okay. So obviously you will have to find out the point Q. Now this is one of the important concepts here. Try to listen to this carefully. Here, as you can see, these two lines are parallel to each other. So if these two lines are parallel to each other, I can say that this line also has the set of drs as 1 comma 2 comma 1 because they are parallel lines, right? Now I'm going to write down the equation of line PQ from here. So equation of line PQ, if you want to write, there is a point on this and there are the drs also. Let's write down x minus 1 divided by 1 is equals to y minus 3 divided by 2 is equals to z minus 2 divided by 1. So this is the line PQ. Now here we are going to use the concept of the point of intersection of a line and a plane, which is one of the most important things and basic things to know. That is how to solve a line and a plane. Once again, a simple logic is, first of all, assume the general point on the line. Okay. And we know that in one of the previous videos also have shown you already how to assume a general point on the line, right? We'll be taking it as is equal to some lambda. Now, if I want to assume this point Q here, which is a point on this line, I can write down that as lambda plus 1 comma 2 lambda plus 3 comma lambda plus 2. Okay, I hope you're able to see that. I want to assume a point on the line PQ, which is the required point Q actually. So if I want to do that, first of all, I'll have to take that is equal to some lambda and write down the values of x comma y comma z. Now, what is the main observation here? This point Q is actually lying on this plane, which means it has to satisfy. Okay, so this is the proper method to find out the point of intersection of line and a plane. Okay, so let us take this point and substitute and get the value of lambda finally. So lambda plus 1 minus of 2 lambda plus 3 plus 3 times of lambda plus 2 is equal to 6. So if you expand completely, 4 lambda minus 2 lambda will be 2 lambda. And in the constant term, let's look at that. It is 6 plus 1, 7, 7 minus 3, 4, and which is equals to 6 minus 4, 2. And finally, we get lambda is equals to 1. Okay, solving part, you can do it right. And then we can take this value of lambda back and substitute to get the point Q here. So finally, you're going to get the point Q as 2, comma 5, comma 3. So you have the point Q with you, and based on this point Q, you can directly check for the option A here. Okay, option A is what? We just need to find out the distance PQ, right? I think you know how to do this one. Distance PQ is equal to square root of, you have the point P and Q, square root of 1 plus 4 plus 1, which will be is equal to square root of 6, which means option A is going to be correct. Okay. Now, what is option B here? We have to find out the coordinates of the point R. Now, let's come back to the question here. This is the only first statement solving. Another straight line which passes through Q and is perpendicular to the plane L1 intersects the plane L2. Okay. Now, let us observe this one carefully. Let's read the question and draw the diagram. So based on the question, this is going to be a diagram. Let me take one more diagram to be clear. This is the plane L1 already known to us, which is x minus y plus 3z is equal to 6. And this is the point Q here. And they are saying that another line which is passing through Q and perpendicular to the plane L1. So it is passing through Q and perpendicular to L1 here. And then they said that this line is meeting another plane at the point R. So once again, you have to solve this line and the plane L2 there. But for that, you need this straight line, right? So once again, what is the idea? Just similar to the previous part we have done, right? But we need the line. So the main idea in this second part is here, this is the point Q, which is nothing but 2, comma 5, comma 3, which we just obtained. Moreover, we need the drs of this line, but what I'll say is directly the drs of this one can be taken as 1, comma minus 1, comma 3. I hope you got this point. What is the reason behind it? Because this line, whatever they are talking about, is simply nothing but the normal to this plane here. Okay. And what did I tell you in the first part that I told you? That the coefficients of xyz in the plane are nothing but the drs of the normal line. So what are the coefficients of xyz here? 1, minus 1 and 3, and those are nothing but the drs of this line. So by using that concept, I'm going to write down the line equation. It is passing through 2, 5, 3. So x minus 2 divided by 1 is equals to y minus 5 divided by minus 1 is equals to z minus 3 divided by 3. Now you need to find out the point of intersection of this straight line with another plane L2. Okay. So let's note down the plane L2 here, which is 2x minus y plus z. 2x minus y plus z is equals to minus 4. And once again, you need to solve this plane and the line. So what's your obvious idea? Again, take it as is equal to some k, from which you get the general point as what? X comma y comma z is equals to k plus 2 comma minus k plus 5 comma 3k plus 3. And it is similar to the previous one. What we have done? We have found out the general point on the line and simply took that and put it in the plane. So take this general point, substitute in the plane. What you are going to get is 2 times of k plus 2 minus of minus k plus 5 plus 3k plus 3 is equals to minus 4. So if you solve properly, this is 2k plus k, 3k, 3k plus 3k, 6k. And constant terms are plus 4 minus 5, which is minus 1. and minus 1, so plus 2, which will be minus 6. So finally you get k is equal to minus 1. So take this value of k and substitute back in the general point to get the point of intersection of plane and the line. So if you substitute that, you get the required point r, which is 1 comma and 6 comma 0. Okay, I hope you are understanding, because it is just as similar to the previous part that we have done. So successfully we have found out the point r also. And look at the option B here. What is option B? Nothing but point R is given as 1 comma 6 comma 3, right? But what we have got is 1 comma 6 comma 0. So which means it is false. Okay. And then we have to find out the center of the triangle PQR for option C. But you know the formula, right? In three-dimensional coordinate system, what is the formula to find out the centroid x1 plus x2 plus x3 divided by 3, comma y1 plus y2 plus y3 divided by 3. So this will give you the centroid. But since you know all the 3 points, right? Point P is given to you, Q and R we just found out, and you know how to verify for the option C. Now I'm going to leave the solving part to you because it is very simple. And then the perimeter of the triangle PQR. Now you know what to do, right? Because you have the 3 points with you, P, Q, and R, like this. P, Q, and R. So all the 3 points are known to you. And what is option D once again here? You have to find out the perimeter of the triangle PQ. What is the meaning of perimeter? We just need to find out the sum of these distances, PQ plus QR plus PR. And you know very well how to find out the distance between the points. And once again, you can check the fourth option by yourself. I'm leaving the solving part to you. Okay. So as you can see here, one single question in JEE Advanced here is made up of different concepts: centroid, distances, perimeter, solving line and plane, and solving point of intersection using another line parallel to another line. So that is why I told you, right? When we try to finish the PYQ means, we will get a good clarity on the basics part, and we can use that basics part to solve any previous advanced question. Okay. So don't neglect the planes chapter in JEE Advanced especially, because this is, I think, from my point of view, this is one of the question where you can score perfectly and easily in the JEE Advanced. Okay. So I hope you have understood these examples, right? So I try to cover all the concept that I discussed till now by, by discussing all these questions, right? Okay. Now let's see some more properties and concepts related to planes here. One important thing is, let's take a plane and let us assume the equation is some ax plus by plus cz plus d is equals to 0. Okay, let us take the plane like this. Now, if this plane is parallel to x-axis, if this plane is parallel to x-axis, you need to imagine that the plane here is clearly parallel to x-axis. Now, the point here that I'm trying to say here is, if you take this normal to this plane, something like this here, I can say that this normal also will be perpendicular to the x-axis here, right? That point is clear. And we know that since the coefficients of x comma y comma z are abc here, I can take the drs of this normal as some a comma b comma c. And we know how to take the drs of x-axis also. You can take it as directly 1 comma 0 comma 0. But this x-axis and this normal are perpendicular to each other. And what happens if two lines are perpendicular to each other? A1 a2 plus b1 b2 plus c1 c2 is equals to 0. So that is what I'm going to apply, which is 1 into a plus 0 into b plus 0 into c is equal to 0. On solving, you get a is equal to 0. So if you put this back in the plane equation, we get something like this, that is by plus cz plus d is equals to 0. So this is the general equation of the plane which is parallel to x-axis. Okay, so the simple trick here to remember is, whenever a plane is parallel to x-axis, there won't be any x term in the plane equation of general form. Okay, similarly, you can write down other 2 points also. If a plane is parallel to y-axis, it will be of this form, that is ax plus cz plus d is equals to 0 if the plane is parallel to y-axis. Similarly, if the plane is parallel to z-axis, So if the plane is parallel to z-axis, the equation will be of this form. Ax plus by plus d is equals to 0. Okay, na? So this will be helpful whenever in the question directly they say that the plane is parallel to x-axis or y-axis and z-axis. Okay, so this is one important point. And one more thing we need to understand here is just imagine the diagram here. Let's take this as some x-axis. This is y and z. This is origin. Okay. Now I want you to imagine any plane which is parallel to x-axis. Okay. So let me take it something like this here. So I can say here that this plane is clearly parallel to x-axis, right? So what exactly happens is whenever a plane is parallel to x-axis, it will be definitely perpendicular to y-o-z plane. Okay, I'm going to write that here in the brackets. If a plane is parallel to x-axis, the plane is also perpendicular to y-o-z plane. Okay, and similarly, if a plane is parallel to y-axis, then the plane is perpendicular to xoz plane. Similarly, if a plane is parallel to z-axis, then the plane is perpendicular to xoy plane. Okay, so these are some special points related to planes parallel to the coordinate axis, or also called as coordinate planes here, xoy, yoz, and xoz planes. Okay. Now, next important thing is, until now, whatever questions we have done and concepts we have taken here, all these are based on Cartesian form of the planes. Okay, but sometimes the plane equation will be given in terms of vectors. Okay, I'll tell you some examples and I'll tell you how to convert a vector form into Cartesian form, because generally we can solve all the questions using Cartesian form only. So, what the trick here is, suppose there is a plane equation given to you like this. Okay, plane equation something like r bar dot 2y cap minus 3j cap plus 5k cap is equal to minus 3. So this is how they'll say. Consider the plane given by r bar dot 2y minus 3j plus 5k is equal to minus 3. So we have all the formulas, most of the formulas based on Cartesian form only, right? So whenever you want to consider write this vector form of plane to Cartesian form, you just need to take this r bar as some xi cap. That's a general point, right? So take it as xi cap plus yj cap plus zk cap. Now, if you directly do the dot product of these two, what will you get? Obviously, 2x minus 3y plus 5z is equal to minus 3. So this is your plane equation directly. Okay. So this is how you have to convert your plane equation, which is given in terms of vectors, to Cartesian form. I hope you got that point. Simply put that r bar as xi plus yj plus zk and then do the dot product, and the resultant is going to be your equation of plane. Or also very directly you can say the coefficients of I, j, k on that left hand side are nothing but the coefficients of x comma y comma z in the general equation of the plane. Okay. If you want, I will write one more example. Let's say r bar dot I cap minus k cap is equals to 5. If this is your given equation of the plane. So directly, what is your equation of plane here? It should be x I cap plus y j cap plus z k cap dot product with I cap minus k cap is equals to 5. And you can do the dot product from which you get x minus z is equals to 5. So this is your equation of the plane. Okay. And sometimes you will have to convert Cartesian form into the plane which is in vectors. Okay, so that also you can do directly. Suppose if I have a plane equation 2x plus 5y minus of 3z is equal 3z plus 7 is equals to 0. Okay, let's say I want to write this in terms of vectors. Once again, you need to express this 2x plus 5y minus 3z in terms of vectors using dot product. What you can do, obviously, I can write this as xi cap plus yj cap plus zk cap dot product with the coefficients of xyz are nothing but the coefficients of ijk here. So which will give you 2y cap plus 5j cap minus 3k cap and plus 7 is equal to 0. And then this is your r bar vector, and finally you can write down r bar dot 2y cap plus 5j cap minus 3k cap. and that is equals to -7. So this is how you convert your Cartesian equation of plane into the plane which is in terms of vector. Okay, so that interconversion should be done very carefully and without a second thought in the examination. Okay, now. So this is how we convert planes in Cartesian form to planes in the form of vectors. Okay. And now the next thing is, here we have written few cases, right? That is plane passing through 3 points, 2 points, and 1 point, and parallel to two other lines. And all those should be also written in terms of vector forms also. So let us try to see that first. So let's take a plane which is containing three given points. Okay, I will take that as point A bar, point B bar, position vectors. Okay, in terms of vector, we are going to write this point C is C bar. Now I have to write down the equation of plane in terms of vector form here. Okay, so if you want to write down the Cartesian form, what we can do, you can simply convert this position vectors into Cartesian points. For example, if you have the point A given as some I cap plus j cap plus k cap, what is the corresponding Cartesian form? 1 comma 1 comma 1. So you can convert in that Cartesian form and you can still do it, but here we are going to use the vector forms of the plane. This is also very important actually. Okay, so try to listen to this carefully. And once again, we have the tricks. Obviously, I will tell you how to write down the plane equations quick by using a simple trick. Once again, what I am going to do is assume the general point P whose position vector is r bar. So this time I am going to form three vectors AP bar, AB bar, AC bar. Okay. So what we can say about these three vectors clearly, the three vectors AP bar, AB bar, AC bar are clearly lying in the same plane in this case, which makes the three vectors as coplanar vectors, right? So now, if you remember, if you recall, whenever we have three vectors, for example, A bar, B bar, and C bar, A bar, B bar, C bar, which are coplanar vectors, what is our simple idea? That you can express any third vector as the linear combination of other two, right? I can write it as some S into B bar plus T into C bar, right? Whenever we have three coplanar vectors, A bar, B bar, and C bar, we can write down any vector as a linear combination of other two. So I can write C bar is equal to some S into B bar plus T into C bar, where S comma T are scalars here. So I'm going to use that logic here. AP bar, AB bar, AC bar are coplanar, which means I can express this AP bar as a linear combination of the remaining two vectors, that is S into AB bar, T into AC bar. Okay. Now we know what is AP bar. AP bar is nothing but OP minus OA. But OP here is R bar minus of OA is nothing but A bar is equal to S into AB bar is nothing but OB minus OA, which will give you B bar minus A bar plus T into AC bar is nothing but C bar minus of A bar. Now from here finally we are going to write down the position vector of R bar. So I will take everything to right hand side. And then let me take A bar common first of all. A bar multiplied by 1 minus S minus T. And then plus S into B bar plus T into C bar. So this is your vector form of the plane, which is passing through three given points with position vectors A bar, B bar, and C bar. Okay, where S comma T are scalars in this case. Okay, so this is how you write the equation of plane in vector form. As I told, every time trick will be there. What is the trick here? The trick is to form three coplanar vectors every time. Okay, so I'll take one more case also, then you will understand how to take the coplanar vectors. Okay. And what was the next case that we discussed in Cartesian form? A plane which is passing through two given points, right? So I will take two given points A and B with the position vectors as A bar, B bar, and then that is also parallel to another given vector. Okay, so let's take this vector as something like L bar. Okay, anything, it can be anything actually. So as you can see here, there is a plane which is containing two points A and B whose position vectors are A bar and B bar. and that plane is also parallel to L bar here. So once again, our idea, there is no change. First thing is always assume your general point P, that since it is vectors form, take it as R bar. Once again, what I'm going to do is form the vector AP bar, form the vector AB bar, and then now you can see one thing very clearly. AB bar are lying in the same plane. Moreover, that L bar is also parallel to this plane, which makes the three vectors here, AP bar, AB bar, and L bar, coplanar here. Because what is the meaning of coplanar vectors? Three or more vectors are said to be coplanar if they are lying in the same plane or also in the parallel plane, right? So that is the reason. Now once again I'm going to use the same logic here. So finally AP bar is equal to S into AB bar plus T into L bar. Okay. And we know how to resolve this into position vectors, right? AP bar is nothing but R bar minus A bar, which is equal to S into AB bar is B bar minus A bar and plus T into L bar. Okay. So finally I can write this as R bar is equals to A bar multiplied by 1 minus S plus S into B bar plus T into L bar. So this is the vector equation of plane in this case. Okay, so the idea here is to form three coplanar vectors every time. Okay, now what was the next case that we have discussed actually? A plane which is containing a given point and parallel to two lines. Okay, so let's take the point given point as some point A bar here. Now I will take the two parallel lines to be something like this. Look at the diagram. So this is one vector, lines are also vector. So if I, okay, let's do one thing. I'll try to write down the line equation in terms of vector form. We know very well, right? If I write this as R bar is equals to some A1 bar plus lambda into B1 bar. So if you recall, what is the meaning of this one? Let's try to recall. Whenever we write R bar is equals to A bar plus lambda into B bar, what is the meaning of this one? It is a line which is passing through A bar and also parallel to the vector B bar. So whatever is the coefficient of B bar here, quotient of lambda here, that is going to give you the parallel vector. So based on that logic here, what should be the meaning of this line here, a1 bar plus lambda into b1 bar, which means this line over here is parallel to the vector b1 bar. Okay, so that's what you have to understand. And let me write down one more line equation which is parallel to this plane here. So let's take this as R bar is equal to some A2 bar plus some mu into B2 bar. So once again from this line equation I have just written, what do we need to understand? The coefficient of mu here is nothing but a vector parallel to this line. That means any vector parallel to this line can be of the form B2 bar. Okay. And once again, finally, if I want to write down this plane equation, assume a general point P, take it as R bar, and then you try to form the vector AP bar here. But what is the observation? AP bar is lying in this plane, whereas B1 bar and B2 bar are parallel to this planes, which makes the three vectors once again coplanar vectors. So finally, AP bar, B1 bar, B2 bar are coplanar vectors. So once again I can write down AP bar is equal to some S into B1 bar plus T into B2 bar. So finally AP bar is R bar minus A bar is equal to S into B1 bar plus T into B2 bar. So finally we get the vector form of the plane. A bar plus S into B1 bar plus T into B2 bar. So this is the vector form of the plane in this case, where once again S, T are scalars. Okay, I hope you have understood this one. So as I told, there are different ways to write down the equations of the plane. The previous one which we have done was Cartesian form, and this is completely vector form. Okay. So as I told earlier, whenever we see a plane equation of this form, for example, R bar dot some N bar is equals to D. Okay. Immediately you need to get the idea that this N bar here is nothing but the normal vector to the plane. Okay. So for example, if I write R bar dot I cap minus j cap plus k cap is equals to some 3. So what do we need to understand here? This whatever vector is in the dot product, that is simply the normal vector to the plane. Normal vector to the plane. So if I take a plane, something like this, a vector which is perpendicular to this plane can be taken as I cap minus j cap plus k cap. Okay. Or else it can be understood that if I take a line which is perpendicular or normal to this plane, this line will have the drs which are nothing but 1 comma minus 1 comma 1. That is coefficients of ijk will give you the drs of the normal to the plane. Okay now. And now next one. Now we'll try to see some important concepts before going to the next questions. We'll try to see some more concepts, very important concepts related to planes. So the first one is angle between two planes. Angle between two planes. So the concept is very simple actually. Angle between two planes is nothing but the angle between their two normal vectors. Because if you try to observe this, there is a plane something like this. And let's imagine one more plane here. Okay, now we know that this is the angle between these two planes, which is theta here. So the concept here is to find out the angle between any two planes, we just need to find out the angle between their normals actually, because this is a normal to the first line. Let us take it as some L1. And if this is theta, this is going to be 90 minus theta because this is entirely 90 here, right? If this is theta, this becomes 90 minus theta. And then for the second plane, this is going to be the normal line here. Okay. And if this is completely 90 because it is normal here, and out of that, the small one here is 90 minus theta, which makes this as theta. So what is the main observation here? If theta is taken as the angle between the two planes, then theta is also nothing but the angle between the two normals. And that is the main thing that we are going to make use of to find out the angle between two planes. That is, whenever we have two planes in the general form, a1x plus b1y plus c1z plus d1 is equals to 0, and then a2x plus b2y plus c2z plus d2 is equals to 0. So now if I want to find out the angle between these two planes, let it be some theta, then directly our formula will be cos theta is equals to the acute, if you want acute angle, it will be cos theta is equals to modulus of a1 a2 plus b1 b2 plus c1 c2 whole divided by square root of a1 square plus b1 square plus c1 square multiplied by a2 square plus b2 square plus c2 square, right? And what is the reason behind this? It is simply calculating the DRs of two lines whose DRs are A1, B1, C1, A2, B2, C2. Because from the first equation, I can say that the line L1 will have the set of DRs as A1, B1, C1, and the second line will have that set of DRs as A2, B2, C2. And that is how we got this formula here. Okay. But sometimes, as I told you, they might give you the question in terms of vectors also. And that's not a problem, obviously, because let's say the first plane is given to you something like this. R bar dot n1 bar is equal to some d1. Okay, in terms of vectors here. Now let's take the other plane equation, that is r bar dot n2 is equals to d2. So let's say this is equation 1 and equation 2, which are representing two planes here. Now, if I want to find out the angle between these two planes, once again, what did I just tell you? This n1 bar in the first equation is nothing but what? Normal vector, right? So let me mention that if you want. I can say that n1 bar comma n2 bar are normal vectors for the plane 1 and 2 respectively. And once again, just now I told you, if you want to find out the angle between the planes, you just need to find out the angle between their normals. So here n1 bar and n2 bar are the normal vectors. So once again, if you want to find out the angle between two vectors, what will you do? You go for the cos theta formula. So cos theta is equals to n1 bar dot product with n2 bar whole divided by modulus of n1 bar multiplied by modulus of n2 bar. So this is how we do the question in terms of vectors. N1 dot n2 divided by mod of n1 into mod of n2. Okay. So this is for angle between two planes. Now, by using the simple logic here, we need to understand few things. That is, if there are two planes like this, which are parallel to each other, So let me take it as a1x plus b1y plus c1z plus d1 is equal to 0. And then the other plane is a2x plus b2y plus c2z plus d2 is equals to 0. So here I have drawn the planes in such a way that the two planes are parallel to each other. But what exactly happens if the planes are parallel to each other? Their normals will be exactly parallel. I hope you are able to notice this here. This, let's say this is L1 and this is L2, normal to the first plane and also second plane. But what's the main observation? Can you imagine? Just imagine two planes which are parallel to each other. Now imagine their normals also. Very clearly, you will be able to imagine that the two normals also will be parallel to each other. So from the given equations, L1 has the drs A1, B1, C1 and L2 has the drs A2, B2, C2. But we know very well, if there are two lines whose drs are there with us and if the lines are parallel, what's the condition? That the ratios must be same, and that is how we get the property for parallel planes. For parallel planes, we have the condition that A1 by A2 is equals to B1 by B2 is equals to C1 divided by C2. And in the similar way, if the planes are perpendicular, if the planes are perpendicular. So obviously, what is the concept there? If two planes are perpendicular to each other, obviously their normals also will be perpendicular, right? So that is the reason we can write down that A1 A2 plus B1 B2 plus C1 C2 is equals to 0. So these are the two important conditions in the concept of angle between two planes. Okay, now once we know this concept here, how to find out angle between two planes, immediately we need to know one simple concept here. For example, if there is a plane ax plus by plus cz plus d is equal to 0, ax plus by plus cz plus d is equal to 0. Okay, there is a plane something like this. Now, if you want to assume any plane which is parallel to this plane, okay, I want to assume a plane now in the question. Okay, so let's say in the question they are asking there is a plane P1 which is parallel to the given plane P. So if in that case, if you want to assume that plane, you can simply change the constant and assume it, just like straight lines. You can take the required plane as ax plus by plus cz plus some lambda is equals to 0. So the trick here is very simple. That is, the equations of two parallel planes will only differ by a constant. Okay, so as you can see here, this ax plus by plus cz part is same and only the constant terms are different here. Okay, so that's how we try to assume the parallel plane to a given plane. Okay, I hope this is clear. And then next important thing, if there are two parallel planes, for example, ax plus by plus cz plus d1 is equals to 0, and then ax plus by plus cz plus d2 is equals to 0. I hope you're able to see this one, that the coefficients of x, y, z, I made sure they are same because I'm trying to indicate the two planes are what? Parallel to each other here. Okay. Now, just imagine this scenario. This is a plane and this is another parallel plane. Now, I want to find out the distance between these two parallel planes. What is the meaning of the distance between two parallel planes? Meaning is, if you pick any point on one of the plane, you just need to find out the perpendicular distance to the other plane, and that is nothing but distance between the parallel planes. So let's call it as P here. So finally, the result is the distance between two parallel planes. Distance between two parallel planes is directly given by modulus of d1 minus d2 divided by square root of a square plus b square plus c square. A very, very important formula. And as you can see, it is almost similar to the formula, that is C1 minus C2 divided by root of A square plus B square from the straight lines concept, right? Just one extra term C is added here. Okay. So this is the concept of distance between two parallel planes here. And moreover, as I told you, that concept is also important. How do you calculate the distance between two parallel planes? You pick any point on one of the plane and you try to find out the perpendicular distance to the other plane. Okay, so very important. Next important thing, this is also one of the most important thing. For example, let me take a plane here and whose equation is ax plus by plus cz plus d is equals to 0. Okay. Now, there is a straight line, something like this. Okay. Let me take the straight line as some x minus alpha divided by some a1 is equals to y minus beta divided by b1 is equals to z minus gamma divided by c1. Okay. Now the concept is to find out the angle between the line and the plane. Okay. So for that, our idea is, if this is your required angle, some theta 1. Okay, let me take it as some theta 1, where theta 1 is clearly what? The angle between the line and the plane. Okay, now to find out this theta 1, the concept, the idea here is, first construct the normal to the plane. So let me construct the normal to the plane like this here. Okay, now if it is normal like this here, which means it is perpendicular obviously, and as you can see here, if I take this angle between the normal and also the line here, given line here as some theta 2, okay? And by looking at the plane equation, we have the dr's of the plane as what? Dr's of the normal to the plane as what? A comma B comma C. Now, what I'm going to do is, first, I'll try to find out the angle between the given line and the normal, okay, by using cos theta formula. So let me write down cos theta 2 is equals to, because the normal has the dr's ABC, and what about the dr's of the line here? Nothing but A1, B1, C1, right? So we know how to write down cos theta 2 is equals to A1 plus B1 plus C1 whole divided by sigma of a square. So let me write down directly what is the meaning of sigma of a square here. A square plus b square plus c square. Similarly, I'll write down square root of sigma of a1 square. And what is the meaning of sigma a1 square here? A1 square plus b1 square plus c1 square. So we have cos theta 2. Okay. Now, I can write down theta 2 as nothing but cos inverse of a1 plus b1 plus cc1 whole divided by square root of sigma a square multiplied by square root of sigma a1 square. Okay, and this is not the required angle actually, because our required angle is theta 1. But what's the pure observation here? That theta 1 plus theta 2 is equals to 90. Theta 1 plus theta 2 is equals to 90. So what is our required angle from here? Theta 1. So theta 1 is nothing but pi by 2 minus theta 2. So if you substitute this theta 2 here, what you get? You get theta 1 is equals to pi by 2 minus theta 2. So theta 2 is something like this, cos inverse of some function. But we know from inverse trigonometry, pi by 2 minus cos inverse of x is nothing but sine inverse of x. So finally, we get our required angle. Let me mention angle between line and plane is sine inverse of the above value modulus of A1, BB1, CC1 whole divided by square root of sigma A square multiplied by square root of sigma A1 square. So this is your final formula to calculate the angle between the normal, sorry, the given line and the plane. Sine inverse of mod of AA1 plus BB1 plus CC1 divided by root over sigma A square into root over sigma A1 square. And what are ABC and A1, B1, C1 here? They are nothing but the DRs of the normal and the given line respectively. Okay. And once again, the same thing can be obtained by using vectors also, because sometimes in advance they'll give you the question in terms of vectors also. And once you understand this concept, the procedure is simple. Because if I take the plane equation as some r bar dot n bar is equals to d, r bar dot n bar is equals to d, and then there is a straight line given to you, something like this. That is r bar is equals to some a bar plus lambda into b bar. Okay, let me take the line as r bar is equal to a bar plus lambda into b bar. So once again, what's our idea? That is, you will take this as theta and theta 1 and theta 2, and then finally you can, I mean, because if you take this line as r bar is equal to a bar plus lambda into b bar, what do we need to understand? That this line will be parallel to a vector b bar, right? So that is why, and moreover, you have the plane equation as r bar dot n bar is equal to t, and what is n bar representing actually? This normal vector, right? So this is your normal vector n bar, and again you will take this as theta 2, this is theta 1. But what is actually theta 2 using vectors here? Nothing but cos theta 2 will be is equal to dot product, right? That is b bar dot n bar divided by mod b into mod n. And from there you get theta 2 is equals to cos inverse of b bar dot n divided by mod b into mod n. And finally, what we want is theta 1, which is nothing but pi by 2 minus theta 2. If you take that theta 2 and substitute back here, again you get something like pi by 2 minus cos inverse of x. What is pi by 2 minus cos inverse x? Sin inverse x. So finally, we get the required formula. Theta 1 is equals to sin inverse of b bar dot n bar whole divided by modulus of b bar multiplied by modulus of n bar. So this is the formula to calculate angle between a line and a given plane in terms of vectors. Okay, I hope it is clear. So we need to learn both the methods here, and if you have the proper idea how to calculate the angle, it is a simple concept. Definitely it is not a difficult one. Okay. Now, along with this, we need one extra point also, one of the frequently asked questions. Okay, try to listen to this carefully. Let's say there is a plane. A plane is perpendicular to two given planes, a1x plus b1y plus c1z plus d1 is equals to 0, and a2x plus b2y plus c2z plus d2 is equals to 0. Okay. Now the concept is very important here because it's one of the frequently asked question. They will simply say that there is a plane which is perpendicular to two given planes. Okay. Now you need to understand the concept here. Here, what is the normal drs of this first plane? Nothing but a1 comma b1 comma c1. And what is the set of drs of the second plane here? Directly it is a2 comma b2 comma c2. Right. Now just imagine what happens if two planes are perpendicular to each other. Just now we have discussed it. If you go through it, this one here. So what happens if two planes are perpendicular to each other? Their normals also will be perpendicular, right? I hope you are able to imagine the diagram. This is first plane and this is second plane here. So this is the normal to the first one and this is the normal to the second one. And what's the main observation? Whenever there are two planes which are perpendicular to each other, then their normals also will be perpendicular. So that is the reason, if there is a plane perpendicular to two given planes, obviously what happens, the normal to the required plane will be perpendicular to the first normal as well as second normal. Okay, and that is the reason what we are going to do is to find, I'll write the trick here, to find drs of required plane here. To find the drs of the required plane, simply take their cross product. That is I cap, j cap, k cap, a1, b1, c1, a2, b2, c2. Okay, and you get something like this, right? I cap, j cap, k cap. So it will be I cap into something plus j cap into something plus k cap into something after solving it. Now, whatever the coefficients of I, j, k that you're going to get after solving this determinant, that coefficients of I, j, k are nothing but the normal drs of the required plane. Okay, so once again, if a plane is known to be perpendicular to two given planes, now to find out the drs of that required plane, what you're going to do is simply do the cross product of drs of first plane and second plane, and whatever are the coefficients of I, j, k that are going to be the normal drs of the required plane. Okay, so this is one of the most important property you have to remember. There were many questions based on this. Okay, so after this property, we need two more most important points before we start our questions based on this properties, whatever we have discussed. So let's take the two properties, very important. Try to be very, very careful and concentrate here. Let's say we have a plane and we have two lines in this which are not parallel to each other. Okay, make sure they are not parallel. So let's say the first line is something like this: x minus of alpha 1 divided by a1 is equals to y minus of beta 1 divided by b1 is equals to z minus of gamma 1 divided by c1. And let us take one more line here, which is, as I told, they should be non-parallel. And this second line equation is x minus alpha 2 divided by a2, y minus beta 2 divided by b2 is equals to z minus gamma 2 divided by c2. Okay. Now the concept here is we have to find out the equation of this plane. Whenever there are two given lines in a plane, we have to find out the equation of the plane here. Okay. So there are different ways to solve these kind of questions. The best method is first thing you need to find out the drs of the normal. Okay. For that, the simple trick is drs of normal. The simple trick is do the cross product of their drs. First of all, take the drs of first line a1 b1 c1 and then a2 b2 c2. Okay, so take the cross product of drs of the two straight lines. Now, again, if you expand this, you're going to get something like this: I cap into something, j cap into something, k cap into something, right? So the coefficients of I, j, k are going to be the drs of normal here, the drs of normal to the plane. Okay, and next thing is what? To find out equation of any plane, what do we need? We need the drs of the normal, which we have found out just by using the cross product concept here. And we need a point on the plane because we can use the first form of the plane, that is a into x minus x1 plus b into y minus y1 plus c into z minus z1 is equal to 0, right? So as you can see, based on the first line, I can say that there is a point A, alpha 1 comma beta 1 comma gamma 1, which is lying on the plane, because if the line is lying on the plane, then the point is also lying on the plane, because the point itself is lying on the line and the line is lying on the plane, which makes the point lying on the plane clearly. Okay, so that is why what you need to do is take the point on the line, which is alpha 1 beta 1 gamma 1. So you have a point on the plane, you have the drs of the normal to the plane. Use this and obtain the plane equation. Okay, I hope you understood what to do. So once again, what will you do is take the cross product of the drs of the two straight lines. You will get the coefficients of I cap, j cap, k cap as nothing but the drs of the normal to the plane. And second thing is, from any of the two lines, take the point, because you know that when you have the straight line equation in that form, alpha 1, beta 1, gamma 1 is a point on the line, right? And that is why out of the two lines, pick any line and you write down the point on the line. So you have a point on the plane, you have the drs of the normal, and use the first form, a into x minus x1 formula is there, right? So use that formula to obtain the plane equation. Okay. And once again, when I was starting this concept, I told you, right, this is the case where the two lines are non-parallel here, because you can understand what happens if the lines are parallel. If the lines are parallel, then in the determinant here, the second row, third row becomes proportional. You will get the coefficients as 0, which is not correct here. Okay. So in that case, we have to move in a different way. Let's take that case also. That is also important actually. Let's try to understand that carefully. Now, this time you have two lines in the plane, but here the two lines are parallel to each other. So let me take it as L1. X minus alpha 1 divided by A is equals to y minus beta 1 divided by B is equals to z minus gamma 1 by C. And then the second line L2 here is x minus alpha 2 divided by A, y minus beta 2 divided by B is equals to z minus gamma 2 divided by C. I hope you can notice why I have written ABC and ABC as the DRs of the lines, because the two lines are what, parallel to each other. Okay. So in this case, we have to think differently. That is, to find out the line equation, what I'm going to do is, based on the first line, I can say that there is a point A on the first line, which is alpha 1, beta 1, gamma 1. Similarly, on the second line, we have one more point. Let me take it as point B here. That is nothing but alpha 2, beta 2, gamma 2. Okay, now what I'm going to do is form the vector AB bar. Okay, remember the process. This is not a formula. Remember the process here. What you do is form the vector AB bar. Okay, now take the DRs of this plane here. Okay, otherwise, if you want, I'll write down the formula directly. So what I'm going to do is I'm going to take the cross product of these two DRs, that is ABDRs. ABDRs are what? Alpha 2 minus alpha 1. Let me write it clearly. So I cap, J cap, K cap. So you take the DRs of AB bar here. Alpha 2 minus alpha 1, beta 2 minus beta 1, gamma 2 minus gamma 1. Similarly, the other one is the DRs of any one of the line L1 and L2. And I hope you're understanding what is the reason behind this, right? Because whenever you do cross product of two vectors, what will you get from vectors concept? Think properly. If you take the cross product of two vectors, what vector you are going to get? You are going to get a vector which is perpendicular to both of them, right? Now, in this case, imagine the scenario. AB bar is a vector lying in this plane like this, and then if this is a line L2 here, I can say that this line will be along the vector some AI cap plus BJ cap plus CK cap, right? So these two vectors are clearly lying in this plane. So if you take the cross product, what you are going to get? You simply get a vector which is perpendicular to this entire plane, right? So that is the reason what you are supposed to do is, from the first line, take the point alpha 1, beta 1, gamma 1, name it as point A. From the second line, take the point as alpha 2, beta 2, gamma 2, take it as point B. Find out the DRs of AB and put that in the second row. First row, obviously IJK, because it is a cross product. And third row is put the DRs of the any of one of the line A, comma B, comma C. And once again, you're going to get something like this: I cap into J cap into K cap into. So the coefficients of ijk will again give you the DRs of normal. Coefficients of ijk will give you DRs of the normal. And once again, once you know the DRs of the normal, you can either use the point A or point B because they are the points on the plane. So you have a point on the plane and you have the DRs of the normal. Okay, I'll write it here. Use A or B as a point on the plane, and you have the point on the plane, you have the DRs of the normal. Again, use the first form to find out the equation of the plane. Okay. So the second case is where you have to be very careful. Don't try to use the first formula in the second case. You will get 0 is equal to 0, which will not be correct here. Okay. So these are the 2 points which you must remember, because there are many questions based on the concept where you have to find out the equation of the plane containing two given lines. Okay, right. So now what we'll do is we'll try to see some most important PYQ questions from planes chapter, which will be definitely very important for your upcoming JEE Advanced in planes chapter. Okay, so let us try to see 10 questions which are potentially important for your JEE Advanced upcoming exam. Okay, So the first one, if lambda 1 less than lambda 2 are two values of lambda such that the angle between the two planes, so let me write down the planes here, r bar dot 3 I cap minus 5j cap plus k cap is equals to 7. Second plane equation is r bar dot lambda into I cap plus j cap minus of 3k cap is equals to 9. Okay. So as I told you, what is our simple concept here? Convert this vector form into vectors equation into Cartesian form. I told you that trick also, right? So what's the plane equation in the first case? It is 3x minus 5y plus z minus 7 is equal to 0. And from the second vector form, I can write down the plane equation as lambda into x plus y minus of 3 into z minus 9 is equals to 0. So you have both the plane equations here. Now what they are saying is the angle between the two planes is theta is equals to sine inverse of 2 root 6 divided by 5. Okay. But if you remember, I already gave you the formula. Look at this one. So this is our formula, right? This is a formula to calculate. I'm sorry. I think this one. Yeah, this one. Whenever you have the two planes, you know how to find out the angle between them. It is directly what? Cos inverse of a1, a2 plus b1, b2 and so on, right? So let us do that. First of all, cos theta. So if theta is the angle between these two planes, we know the formula cos theta is equals to a1 a2, that is 3 into lambda plus b1 b2, which is minus 5 and minus 3, and whole divided by square root of a1 square, that is 9 plus 25 plus 1 multiplied by square root of this is lambda square plus 1 plus 9. Okay, so you have to remember the formula for this. And then here this is sine theta, right? So if this is sine theta, that is sine theta is equals to 2 root 6 by 5. And we know how to find out cos theta, right? So sine theta is 2 root 6 divided by 5. Let's calculate the adjacent side, 25 minus of 24, which is 1. So what is cos theta from here? Cos theta will be is equals to 1 divided by 5. Take it and substitute it here. So you get 1 by 5 is equals to modulus of 3 lambda minus of 8 divided by square root of 35 multiplied by square root of lambda square plus 10. And you can cross multiply and square on both sides here. You get 35 into lambda square plus 10 is equals to 25 multiplied by 3 lambda minus 8 whole square. Now you can cancel this as 5 5 and 5 sevens, and you can expand the remaining part. 7 lambda square plus 70 is equals to, this is 45 lambda square plus 64 into 5, and then minus of 5 into 3 into 2, 24, 24 to 48 times of lambda. Okay, I hope you will do the calculation of this one. I'm leaving the solving part to you, because once we expand this equation, you get a quadratic equation in terms of lambda, which will obviously give you two values of lambda, that are lambda 1 comma lambda 2. Now read the question and try to observe whether you will be able to do the remaining part or not. They said that lambda 1 and lambda 2 are the two values of lambda. So you will solve that and get the values of lambda 1 and lambda 2. And after that, what is the required part? Then the square of the length of perpendicular from the point to the plane P1. So clearly, this equation 1 is your plane P1. And once you know this lambda 1 and lambda 2, you can substitute and get the point. And in the previous question also, I have told you already how to find out the perpendicular distance from a given point to the given plane. Okay, so I'm leaving the solving part to you, just to try to get the concept here. And once again, what is the thing that we are using here? Concept of angle between two planes, that is cos theta is equal to sigma a1 a2 divided by root over sigma a1 square multiplied by sigma a2 square. Okay, let's take the next question. This is one of the previous mains question once again. If the equation of the plane that contains the point minus 2 comma 3 comma 5 and also perpendicular to the two given planes, that is 2x plus 4y plus 5z is equal to 8, and then 3x minus 2y plus 3z is equals to 5. And just now I gave you one property. What is that? Whenever there is a plane which is perpendicular to two given planes, what is the idea to calculate the drs of the normal? Simply take the cross product of the drs. So let us do that. I cap, j cap, k cap, and the drs are 2, 4, 5, 3 minus 2, 3. Let's expand this one. So it will be I cap multiplied by 12 plus 10, which is 22, minus of k cap multiplied by, sorry, j cap multiplied by 6 minus of 15, right? Which will be minus 9, and plus k cap multiplied by minus 4 minus of 12, which is minus 16. And finally, what we get is 22 I cap plus 9 j cap minus of 16 k cap. So these, as I told, the coefficients of ijk here are nothing but the drs of the normal, 22 comma 9 comma minus 16. So these are your drs of normal. Now let's go back to the question. They said that there is a plane which is containing the point. So this is like x1 comma y1 comma z1, and this is like a comma b comma c. So you have abc, you have x1 y1 z1, and what is our first case? A times of x minus x1 plus b times of y minus y1 plus c times of z minus z1 is equals to 0. So put that here and solve the remaining part, which will be 22 into x plus 2, and b value is plus 9, multiplied by y minus of 3 plus c value is minus 16, multiplied by z minus of 5 is equals to 0. You can expand completely, that is 22x plus 9y minus of 16z. What about the constant terms here? 44 minus 27 and plus 80, which is 124 minus of 27, that is exactly plus 97. Okay, so as you can see, it is given as alpha x plus beta y plus gamma z plus 97. So alpha, beta, gamma are nothing but 22, 9 and minus 16. So from there you can find out whatever they are asking. So as I told, it is one of the very important property, that is plane perpendicular to two given planes. Okay, let's take the next question. And once again, this is one of the PYQ questions and very important model because it is covering many concepts. As you can see, it is involving tetrahedron and also intercepts of the plane, and also one more equation, that is construction of plane. So let us try to read the question carefully here. A plane P is parallel to two lines whose direction ratios are given. Okay, let us try to draw a diagram and get the proper idea here. Okay, always think of the diagram whenever a question is given to you. So there is a plane P, and this plane P is parallel to two given lines, right? And the drs are also known to you, which is minus 2 comma 1 comma minus 3. And once again, one more line is there whose drs are minus 1 comma 2 comma minus 2. And also they said that it contains the point 2 comma 2 comma minus 2. So let me take it as some point A, 2 comma 2 comma minus 2. Now this is exactly one of the case that I have discussed, that is equation of a plane passing through a given point and also parallel to two given lines. So what was the simple idea? As I told you, even if you don't remember the formulas also, what is our simple trick? Assume the general point, that is point P, x comma y comma z. Form the drs of the AP here, and then simply apply the det of all the three drs that you are having here. So what are the drs of AP here? X minus 2, y minus 2, z plus 2. And then drs of one of the line is minus 2, 1, minus 3, and drs of the other line minus 1, 2, minus 2. And that is equal to 0. Okay, this is our idea. You can go back and look at the formula which I discussed earlier. Now, once you expand this, it will be x minus 2 multiplied by minus 2 plus 6, which will be plus 4, and minus of y minus 2 multiplied by 4 minus of 3, which is 1, plus z plus 2 multiplied by minus 4 plus 1, which is minus 3. So finally, when you expand, 4x minus y minus 3z, and constants are minus 8 plus 2 and minus 6 here. So which will give you minus 4 minus 12. So this is your plane equation. Okay, I hope it is clear up to here. So what is the plane equation? 4x minus y minus 3z minus 12 is equal to 0. So the main thing is question is not over yet. It is framed very beautifully. Read the question now. Let the plane P intersect the coordinate axis at the points A, comma B, comma C, making the intercepts alpha, comma beta, comma gamma. Now, this is again similar to one of the previous questions that we have solved, right? That is finding the intercepts. So let us convert into intercept form. It is 4x minus y minus 3z is equals to 12 divided by 12. What you get? X divided by 3 plus y divided by minus 12 plus z divided by minus 4 is equals to 1, where clearly the intercepts are a comma b comma c, which are the denominators in the intercept form. So what did they say here? They said that it is making intercepts of alpha comma beta comma gamma respectively. Okay, so which means this is alpha, this is beta, and this is gamma. And we know what are the intercepts here, right? That is point A is nothing but 3 comma 0 comma 0. Point B is 0 comma minus 12 0, and point C is 0 comma 0 comma minus 4. Now we have got all the 3 points A comma B comma C, but still the question is not over, because they said that V is the volume of the tetrahedron OABC here. Now for this you need to recall the concepts of tetrahedron from vector chapter. So I'll tell you in brief. If you take a tetrahedron something like this here, this is A, B, C, and this is point O, and this is your tetrahedron OABC. So clearly OA, OB, OC are coterminous edges here. So whenever we have three coterminous edges OA, OB, OC, what is our volume of the tetrahedron directly? Volume is equals to 1 by 6 into box of OA bar, OB bar, OC bar. And then we know how to construct OA bar, OB bar, OC bar here, because you have the 3 points ABC, right? So finally, I can say the volume is equals to 1 by 6 times of box of OA, OB, OC is nothing but determinant of the vectors, right? So let me do that. Determinant of first vector OA bar is 3, 0, 0. OB bar is 0, minus 12, 0. OC bar is 0, 0, minus 4. And if you expand, what do you get? 1 by 6 into, directly it's a diagonal matrix, right? Modulus of 3 into minus 12 into minus 4. So finally, what you get is 24 units. So that's the volume of the tetrahedron B here. And what is the value of P given here? Nothing but alpha plus beta plus gamma. But since we got alpha, beta, gamma here, you can find out whatever is asking, right? So this is the concept related to this question. Okay, as I told, it's very important, covering a lot of concepts. Okay, let's take the next question. Now, this is also one of the very important conceptual based question. Let us try to understand carefully. There is a plane passing through three given points 1, comma 2, comma 3, 2, comma 3, comma 1, and also point C 2, comma 4, comma 2. And if O is the origin and the point P is 2, minus 1, 1, then we have to find out the projection of OP bar on this plane. That is, in the projection of OP bar on this plane is of length. Okay. So the idea here is using geometry actually. Look at this. First of all, obviously, you will need the plane equation. Okay. And before writing down the plane equation, I'll tell you the logic idea behind this question. This is the plane, right? We know how to write down the plane equation because it is one of the form that I discussed, right? Equation of plane passing through three given points. That part you can do it. And O is the origin and P is the point P 2, minus 1, comma 1. Okay. So let us calculate here, because we have to check if this point O is lying on the plane or not. So for that I have to calculate. So x minus x1, y minus y1, z minus z1, x2 minus x1, that is 2 minus 1, 1, and y2 minus y1 is 1, and this is minus 2. Similarly, x3 minus y1, which will be 1, and 2, and minus 1. And let's expand now. It is x minus 1 multiplied by minus 1 plus 4, which is 3. minus of y minus 2 multiplied by this is minus 1 plus 2 which is 1 and plus z minus 3 multiplied by 2 minus 1 1 and let's check it finally which is 3x minus y plus z constant terms are minus 3 and plus 2 and minus 3 so which makes it minus 6 plus 2 that is minus 4 is equals to 0 so this is your plane equation and then next here obviously the origin is not lying on this plane right so let me draw the proper diagram now so this is your point O somewhere here and point B somewhere here and this is the vector OP bar like this okay or you can take line segment also not an issue. Now, what is the idea? We have to find out the projection of this OP on this plane. So, for that, what I'm going to do is, first of all, I'll try to find out the distance OP here. Okay, so let me find out the distance OP here. It will be square root of 4 plus 1 plus 1, distance between origin and the point P, which is equals to square root of 6. Okay, and what I'm going to do is, without changing the direction, I'm going to put the same OP here like this. Okay. Now I'll try to form a right angle triangle here like this. Now the projection is nothing but this distance here. Okay. So let's take it as some O dash and this as P dash here. Very clearly since you are moving it parallelly, OP is equals to O dash P dash here. And if this is a point Q, our required distance is O dash Q. Okay, so O dash Q is nothing but called as the projection length here. If you want, I can give you one more rough diagram before solving it. If this is a line segment and if you have to calculate the projection of this on the plane, you need to draw perpendiculars to the plane like this. And then the distance between the foot of perpendiculars, that is called length of projection. That length here is called length of projection. I hope it is clear. And now what I'm doing is I'm moving this top line parallelly and placing it here so that I form a right angle triangle and then I use the concept of angle between the plane and the line. So what I can do is here I can assume this as theta and we have just now discussed how to find out the angle between a line and a plane, right? So what are the DRs of this OP here? Let me write down. DRs of OP are nothing but 2 comma minus 1 comma 1 and clearly what are the DRs of the normal to this plane here which is 3 comma and write down like this 3 comma minus 1 comma 1 and now you have to recall the formula if you want I can show you one more time here so yeah this one whenever you have the DRs of the plane as ABC and the line DRs as A1 B1 C1 you can find out you can find out the theta by using this formula sine inverse of A1 plus B B1 plus C C1 divided by this one right so I'm going to do that here very important concept yeah so from there I will get sine theta so sine theta is equals to what's our formula A1 that is 2 times of 3 plus minus 1 into minus 1 plus 1 into 1 whole divided by square root of this is 4 plus 1 plus 1 multiplied by square root of 9 plus 1 plus 1 so finally we get the value of sine theta which is equals to this is 6 plus 1 7 7 plus 1 8 8 divided by root 6 into root 11 okay so this is the value of sine theta and why do we need sine theta here because if you observe the right angle triangle here I need the length of O dash Q right so I'm going to apply cos theta there okay so cos theta is equals to in that right angle triangle O dash Q that is the projection length divided by hypotenuse O dash P dash okay and if you know sine theta you can find out the cos theta value right if you want I can do the calculation for you quick so sine theta is 8 and this is hypotenuse root of 66 here. Finally, what is your adjacent side which is 66 minus of 64 that is square root of 2. So cos theta value here will be square root of 2 divided by square root of 66 is equals to O dash Q divided by O dash P dash. But what is O dash P dash here? Same as OP. But what is OP here? Square root of 6. And if you cancel this out, you get root of 11. So finally we get O dash Q is equals to square root of 2 divided by square root of 11. And this is your length of projection of a given line segment on a plane. Okay, this is one of the most important concepts here. And here, as I told, I try to use the geometry construction. So try to go through it again. It is potentially very important for upcoming JEE Advanced. Okay, let's take the next question. This is also one of the PYQ questions. So read the question. Equation of the planes parallel to the plane which are at a unit distance from the point 1, comma 2, comma 3. So this is an easy question actually, but we need to know how to assume the plane. That's why I have taken this question. So equation of a plane parallel to a given plane x minus 2y plus 2z minus 3 is equals to 0. So previously I told you, right, if you want to assume a plane which is parallel to a given plane, you simply change the constant and write. So it is x minus 2y plus 2z plus some constant k is equals to 0. Now what is the question here? The plane is at a distance of 1 unit because it is a unit distance from the point P. Let's call it as 1, comma 2, comma 3 point P. So from this point, the distance to this plane is exactly 1 unit, right? So let's do that calculation. 1 is equals to modulus of, we know the perpendicular distance formula. 1 minus of 2 into 2, 4 plus 3 into 2, 6 plus k whole divided by square root of a square plus b square plus c square will give you 1 plus 4 plus 4. On cross multiplying, we get 3 because square root of 9, right? So 3 is equals to modulus of k, and this is 7 minus of 4, that is 3. Okay, and let's take it as lambda actually in this plane equation because in the question already a constant k is involved, right? Let me take the constant in the plane as lambda just to avoid the confusion, right? So this is modulus of lambda plus 3 is equals to 3. So from which you get lambda plus 3 is equal to plus or minus 3. That is lambda is equals to either it will be 0 or it will be minus 6. Okay. So once we get the two possibilities of the plane, for example, if I try to put lambda is equal to 0 here, lambda is equal to 0 here, I get one of the possibility x minus 2y plus 2z is equals to 0 as one of the possibility of the plane. Similarly, if I put lambda is equal to minus 6, I'll get one more plane x minus 2y plus 2z minus 6 is equals to 0. Okay, and that is the reason you can see in the question itself they are saying equation of planes. They are using the plural word planes because multiple answers are possible. And once you got these planes, you can do the remaining part of the question by comparing with the given equation ax plus by plus cz plus d is equal to 0. I hope you can do the remaining part, right? And this is a concept that we are going to use, that is equation of plane parallel to the given plane. Okay, next let's take the next question. A plane is passing through the point 4 minus 1 2 and also parallel to the straight lines and also passes through the point. Okay, so actually this was a previous mains question and in the options points were given. So what we'll do is we'll try to find out the plane equation. Okay, let's try to find out the plane equation. So what is the question here? A plane is passing through a given point, that is 4 comma minus 1 comma 2, and it is parallel to two given lines like this. So what is the first line DRs here? Clearly it is 3 comma minus 1 comma 2. What about the second line DRs? 1 comma 2 comma 3. And now we have to find out the plane equation. Okay, and I think it is very simple because it is one of the previous concepts we discussed already. What is our first thing? You will assume the general point which is x comma y comma z, and then you will form this ds of this line AP here, and then apply the det is equals to 0. Okay, so det of x minus 4y plus 1 z minus 2, and drs of one line are 3 minus 1 2 and 1 2 3. So if you expand the det directly you will get the plane equation. Okay, actually the question was in the options they put some points, we had to check which of these points are lying on the plane. And I think now you know what to do. Just write down the determinant expansion here, find out the plane equation, and keep substituting all the options to check which of the points will be lying in the plane. Okay, I hope it is clear. Just to recall the form of the plane that I just discussed, I'm discussing this question here. Okay, let's take the next question. This is actually the same question. Mm. Let's take the next one. Mm. The perpendicular distance from origin to the plane containing the two straight lines. Now, as I told, this is again one of the PYQ questions only, and this is exactly the concept which I discussed recently, right? So let's take the question here. We have to find out the perpendicular distance from origin to the plane containing two lines. Okay. So once again, let's recall this is your plane, this is your first line, this is your second line, and clearly you can notice the two straight lines are not parallel to each other. So which means it is one the first case of the two properties which we have discussed, right? And what are the drs of the first straight line? 3 comma 5 comma 7. What are the drs of the second line here? 1 comma 4 comma 7. Okay. Now what is the first thing that I told you? Do the cross product of the drs. Okay, so let us do the det of I cap, j cap, k cap, and then drs of the first line 357, and then drs of second line 147. Just expand completely here. That is I cap multiplied by 35 minus of 28, which is 7, minus of j cap multiplied by 21 minus of 7, which is 14, plus k cap multiplied by 12 minus of 5, which is 7. So if you look at the coefficients of ijk, which are clearly 7 comma minus 14 comma 7, and if you want you can divide this by 7 and take the drs as 1 comma minus 2 comma 1, because what we need is the proportions, right? You can divide by 7, and the result is what? 1 comma minus 2 comma 1. And what are these representing? The coefficients of ijk actually? They are nothing but the drs of the normal to the plane. So successfully we have obtained the drs of the normal. And then what is the next thing that I told you to do? Here, look at the line, any one of the line. So let's take the first line here. So by looking at the first line, what is our basic formula actually? X minus x1 divided by a, y minus y1 divided by b, z minus z1 divided by c, right? So on comparing, what is the point x1 comma y1 comma z1 on this line, which is clearly minus 2 comma 2 comma minus 5. So let me take this as point A. What is the logic here? There is a point on the plane which is A, and we have the drs of the normal also. And what's our formula? The first form, A into x minus x1 plus b into y minus y1 plus c into z minus z1, right? So let us do that. Drs are 1 minus 2 1, so which is 1 multiplied by x plus 2, because that's the point, and minus 2 multiplied by y minus 2, and plus 1 multiplied by z plus 5 is equals to 0. A into x minus x1 plus b into y minus y1 plus c into z minus z1 is equal to 0. So from there you will get the plane equation. Okay, but the question is actually what? We have to find out the perpendicular distance from origin to this plane. But I think you will do the rest of the part, right? That is finding out the plane equation and then finding out the perpendicular distance is not a difficult thing. We have done many questions on that just now, right? Let's see the next question. And this is one of the interesting questions. And once again, this is one of the PYQ question. And once again, it is very, very important for the JEE Advanced because it is involving the concept of tetrahedron. Look at this. A tetrahedron has the vertices P, Q, R and origin. So OPQR is the tetrahedron. And the angle between the faces OPQ and PQR. Okay. So the concept here is there are two planes, because when you take a tetrahedron, totally you have four faces, right? Four triangular faces will be there, obviously. Something like this. Okay. So this is O, P, Q, R. Okay. So if you want to find out the angle between the two faces O, P, Q and also P, Q, R, what you must do is, first of all, you have to imagine a plane, or in this case, a triangular face, which contains this 3 points O, P, Q like this. Okay. You need to imagine a plane which contains this triangular face OPQ here. And then you need to imagine one more plane which is containing the other face of the tetrahedron, that is PQR. Okay, I hope you are able to get this point. So what is that? When you want to find out the angle between two faces of any tetrahedron or also any other geometrical figure also. So first thing, you have to assume two planes which are containing the two faces. What are the two faces here? Faces containing OPQ triangle and PQR triangle. So look at the diagram here. This first plane is containing OPQ plane and the second plane is containing PQR plane. Now, if you had to find out the angle between the two faces containing OPQ and PQR, indirectly, you just need to calculate the angle between these two planes. Okay, so what do you need to calculate? Just the angle between the two planes. Now, how do you find out the angle between two planes? We can use the concepts of vector, right? What is that? If n1 bar is a vector, normal vector to the first plane, and n2 bar is a normal vector to the second plane, what's our formula directly? Cos theta is equals to n1 dot n2 divided by modulus of n1 into n2. This is the exact thing which we discussed earlier for finding angle between two planes using vectors. But the point here is you have the plane which is containing the 3 points OPQ, but how do you find out the normal vector? Again, simply the concept of cross product, right? Because I can form the vectors OP and OQ here. And if I do the cross product of these two, you will get the normal N1 bar, right? Because whenever you do the cross product of two vectors, what is the vector that you're going to get? A vector which is perpendicular to the plane containing both of them. That is the reason N1 bar is equals to OP bar cross OQ bar. Similarly, if I want N2 bar, what I need to do? I just need to take the cross product of two vectors in the second plane. That is, let me take it as PQ and PR. Now you know what to do because here N1 bar is nothing but determinant of I cap, J cap, K cap. And OP bar is nothing but 1, 2, 1. OQ bar is nothing but 2, 1, 3. And then on expanding, we'll get the vector n1 bar. Okay. Similarly, what is the vector n2 bar here? It is determinant of I cap, J cap, K cap. And then what is PQ bar actually? PQ is nothing but OQ minus OP. You know what to do. OQ minus OP will give you 1, minus 1 and 2. And PR bar is nothing but OR minus OP. So let's do that. OR minus OP minus 2, minus 1 and 1. And by using this expansion of determinant, you will get the other vector n2 bar also. And once you know n1 bar and n2 bar, take these two vectors, put it in this formula cos theta is equal to n1 dot n2 divided by modulus of n1 into n2. Okay, so that's how you find out the angle between the two faces of any geometrical figure. Okay, this is one of the most important concepts related to angle between the planes, right? Let's take the next question. This is one of the interesting questions from PYQs. If the point 2 comma alpha comma beta lies on the plane which passes through the 2 points 3, 4, 2 and 7, 0, 6 and also it is perpendicular to the plane. Okay. So if you think of the diagram of this one, it is a very simple question actually. So let us try to get the proper idea for this. So what they are saying is there is a plane like this, right? And then now this plane is also perpendicular to one more plane. Now let me draw that perpendicular plane first. So as you can see, these two planes are clearly perpendicular to each other. And what is the plane equation here? 2x minus 5y is equals to 15. But we know one thing very well. If this plane equation is 2x minus 5y is equals to 15, we know how to write down the drs of the normal line, right? So let us take the normal to this. This is the normal to this plane here, normal. And then the coefficients of x, y, z are directly 2 comma minus 5 comma 0. So you have the drs also with you of this line. Okay. Now this required plane, this is your required plane, right? This is your required plane. And in that plane, we are having 2 points actually. Point A is, let's take this as point A and point B. Point A is what? 3, comma 4, comma 2. and this is your point B, which is 7 comma 0 comma 6. Okay, now this is a given scenario. We have to find out the value of 2 alpha minus 3 beta if the point 2 alpha beta lies on this plane, which means first of all you have to calculate this plane equation, right? So for that, obviously, what's the first step? Always take the general point on this one. Take the general point on this one, which is x comma y comma z. And then once again, I'm going to form three lines here. Look at this AP line and then AB line. I'm going to write down the drs of AP here, which is x minus 3 and y minus 4 and z minus of 2. And then I'll write down the drs of this AB here. Drs of this AB are 7 minus 3, which is 4 minus 4 and then 4. These are the drs of AB. And along with these two lines, if we observe the diagram carefully, this black colored line there, as you can see, I'm trying to highlight this line here, okay, is exactly parallel to the required plane, which means the third line that you can take here is directly 2 comma minus 5 comma 0, okay, and then directly apply the determinant for this one. So determinant will be x minus 3, y minus 4, z minus 2, 4 minus 4, 4, and then 2 minus 5, 0. Expand the determinant, and that is going to be a plane equation. Okay, and you know what to do next, right? Because once you find out the plane equation, what's your idea? Simply take that point 2 comma alpha comma beta and substitute in the plane equation to get the condition 2 alpha minus 3 beta, which is the required part. Okay, so this is the idea. As I told, it's very interesting. If you understand this diagram carefully, it's a very easy question actually. Okay, and once again, what's the simple reason? That AP line, AB line are already in the same plane. Moreover, that normal line to the perpendicular plane is exactly parallel to the required plane. And as I told, what drs you will take either the lines which are lying in the same plane or also a parallel line. And that's how I will do this question. Okay, let's take the next question. The equation of the plane containing the straight line and also perpendicular to a plane containing two straight lines. Okay, again, this is one of the very important models which was asked in the PYQs. Very, very important. So once again, as I already told, if you draw the diagram perfectly, all the questions of the plane are almost easy to moderate. Okay, so I won't say all the questions will be easy. That's why I said easy to moderate. So let's say this is your plane, and this plane is containing the line which is given by x by 2 is equals to y by 3 is equals to z divided by 4. Now you need to imagine a plane which is perpendicular to this plane and also contains two straight lines, right? So before directly putting that plane here, otherwise let's do that, no problem. So let's call this as the second plane, which is exactly perpendicular to this required plane here. Okay, now let's try to draw this plane separately and try to understand one thing carefully. So this is the same plane I'm drawing separately just to make you understand clearly. Now they said that this plane is containing two other lines, right? So let us draw it like this. This is the line given by x by 3 is equals to y by 4 is equal to z by 2, and this is the other line x by 3 is equals to y by 4 is equals to z divided by 2. Okay, now what I'm going to do is, first of all, I'm going to find out the drs of the normal to this plane. Okay, so this is your normal line here. Observe the right side diagram, also not the left side, right side diagram. So this is a normal line, and once again, what's our idea to find out the drs of the normal? Because as you see, this is just one of the previous case we discussed. The two lines are having the drs as what? One of them is having 3, 4, 2. Other one is having 4, 2, 3. This is 4, 2, and 3. I'm sorry. So the second line has the drs as 4, comma 2, comma 3. Now, what is the idea to find out the drs of this normal line? You simply take the cross product, right? So let us do the calculation here. I cap, j cap, k cap. First line has the drs as 3, 4, 2. Second one has 4, 2, 3. So let's expand completely and check what we get. I cap multiplied by 12 minus of 4, which is 8, minus of j cap multiplied by 9 minus of 8, which is 1, and plus k cap multiplied by 6 minus of 16, which is minus 10. So the coefficients of ijk are 8, minus 1, and minus 10. Okay. So now let us take the normal line and put it here, because this is the right side diagram is just the diagram which I have drawn as a rough figure. Now this is your plane, perpendicular plane, and just now we understood that its normal is something like this here. I'm highlighting that, you can notice. And this normal has the drs as what? We have found out just now, 8, comma, minus 1, comma, minus 10. Okay. Now this is the scenario almost similar to the previous question now. We had to find out this plane equation. So once again, to find out the plane equation, what's the first step? Obviously, assume a general point, that is x comma y comma z. Okay. Now this line has the drs as 2 comma 3 comma 4, that is the line which is in the plane, right? 2 comma 3 comma 4. And then here, I can say that by looking at this line here, there is a point 0, comma 0, comma 0 on this line here, because 0, 0, 0 obviously satisfies, right? So look at this concept here now. I'm going to form the line OP here, and I'll write down the drs of OP. So drs of OP are x minus 0, y minus 0, z minus 0. And what is the other line which is in this plane? And that has the drs 2, comma 3, comma 4. Now once again, I have written the drs of two lines which are lying in this plane. Along with that, I need one more drs, which are nothing but the drs of the parallel line there. That is 8, comma, minus 1, comma, minus 10. Now my idea is to simply apply the determinant to this coplanar lines or parallel lines. So x, y, z, 2, 3, 4, 8, minus 1, minus 10. And once you expand this determinant, you're going to get the required equation of plane. Okay, so as I told, it's a very good question which is asked in one of the PYQs. Okay, and obviously very important for the upcoming JEE Advanced also. Okay, so try to go through it again. So in this video, we have almost covered around 75% to 80% of the planes chapter here. And there are few more important concepts actually, which is family of planes and also angle bisectors. So as you can see here, this is just a roadmap to JEE Advanced 2026, right? And this is just episode 1. And in the next episode, I'm going to finish off the remaining concepts of planes, and I'll make sure I'll discuss the PYQ Advanced also in the next video. Okay. And also let me know in the comment section what chapter to take next in this roadmap to JEE Advanced. Okay. Thank you.